Okay. So, good evening, everyone. Okay. Okay, let us start. So, good evening, everyone. And today, as we know, we are going to do like projectile motion part 2. So, let us start that again. One most important point that I'm not going to do the derivations. Okay. I'll just include some of the derivations which are very important. Okay. Next, apart from that, we'll be trying to solve as much as the questions which are required and given. Okay. So, before going to that, first, let me just start with simple problems. Okay, just 2 minutes, guys. Yeah. So now look over it. Okay. So let us start this. So previously, what we did, we tried to calculate the different cases of projectile using the normal vector form of the equations. Okay, and we discussed how many types of projectile are there. Now today we are going to just discuss like what are the formulas, and we will try to calculate some problems based on that. Okay. So first thing is, let us see this what it is given. Let suppose if we now we are going to consider the like normal case of projectile. Let's suppose if we have any kind of particle of mass m. Okay, now it is thrown with some kind of initial velocity making angle particular alpha with the horizontal. Okay, so alpha or theta you can consider whatever it is. So it covers this particular horizontal range r, which can be given as, or we'll try to write that, but before that we'll try to resolve this initial velocity. Now as we know that whenever we have velocity or whatever it is, we can things or any kind of vector which is making some kind of angle alpha with the horizontal or vertical, we can resolve it. We name this component as u cos theta, and we name the vertical component as u sin theta. Now, as we know that along the horizontal, their force is zero, but along the vertical, we have gravity force. That's why we have acceleration downwards over here. And so, due to we'll try to apply the conditions for this case. And what are those conditions? That we know that y will follow the equation as like this displacement in the y-axis or displacement along the vertical axis, whatever it is going to follow what equation? So initial velocity is u sine theta in that particular direction. And let's suppose the particle is over here after some time t. So u sine theta into time t minus half zt square is your what equation for the particle, which is going to follow which kind of curve, which is going to follow y path in some time t. Right or not? Second case is, okay. Second case is for the particle which is following this horizontal path, which we tell that it is a range r, or we say it is a range. So for the horizontal path, you know that you have some kind of horizontal initial velocity, that is u cos theta. So u cos theta, okay, into what? Now let's suppose this horizontal, let's suppose the particle, try to understand, if the particle has reached over here in time t, it has y coordinate and it has x coordinate. Okay, so x comma y, x is given as u cos theta into time t, while y is given as u sin theta into time t minus half zt square. If we follow these equations, we can calculate the total time of traveling, like what is the total time of flight for the particle, and this total time of flight is given as, okay, again you can follow different YouTube videos to see the derivations. So therefore total time of flight is given as 2u sine theta upon g, while the particular this particular range is given as u square. I think for the range it is what is that, u square, something like that. Now u square sine 2 theta upon g, yes or no? So these are the formulas. Now next thing is that this particle is reaching this maximum height at t half, yes or no? So along this particular x axis, the particle is reaching maximum height at t half. So this h max that is attained is given as u square sine square theta upon 2z. So these are the basic formulas which are given in every book, and the derivations which are done in your board classes are also there. Okay, so you can try to implement this and you can try to calculate the answers based upon this. But the question is like, what will happen if we try to throw the particles with like different frame or different respective frames? So we are going to understand that later on. But before that, we'll try to understand what is the equation of trajectory for the projectile. Now, as you know, that whenever a particle which is traveling in the particular xy plane, okay, xy plane, so we know that what is trajectory? We call that, as I have told earlier also, like trajectory is an equation involving Cartesian Cartesian planes. Okay, means if we can create an equation involving this x and y plane, like x and y axes, then we call this particular equation as what kind of equation? Trajectory equation. Now, to be perfectly aware of that, what we can do is like to write that equation, as you know, for a particular projectile which is following this path, which has initial velocity u, okay, and which is making angle theta. We can, as we know, this has u cos theta again, u sin theta again. Okay, so let's suppose the particle has came over here. Let's suppose the particle after some time t. Remember that the particle after some time t has came over here. Now we can create one displacement vector to denote the particular position of the particle or not, and that displacement vector will require the coordinates x comma y. So what that x comma y will be? X will be given as u cos theta into time t, and y is given as u sin theta into time t minus half gt square, as discussed earlier also. Now we know that we can just try to implement this, like this time t can be written as x by u cos theta, and from that I will get as what? U is equal to y is equal to u tan theta into u uh, y is equal to x tan theta, okay, minus half of z x square by, try to understand, like if I put x t is equal to x here, so it will be x square by u square cos square theta. So x square, I'm writing cos square theta as sec square theta, okay, divided by what? U square. So whole relation of the trajectory equation for the projectile is nothing but this. Okay, what is that? That y is equal to x tan theta, and that is equal to, wait, okay, so y is equal to x tan theta minus half g x square sec square theta by u square. Now the question is, I asked that how to represent this displacement vector. Now this displacement vector has two components, x I cap plus yj cap. So x I can write it as u cos theta into I cap. So u cos theta into time t I cap, wait, okay, u cos theta into time t I cap plus u sin theta minus half gt square j cap. Remember that this r is dependent upon time, so I can also take the derivation of this particular thing, like I can take dr by dt, and we can know the velocity vector, means what is the resultant velocity vector over here. We can directly calculate out of this, okay, means we'll not have to do any kind of calculation, right or not? What is the best point of this? That we can calculate this velocity vector which is available at point P. Now this velocity has two components, you know already that it has two components. One, u v sin theta, let's suppose this angle is theta, so this will be also this is also going to be theta, and therefore it will have two components, one v cos theta and another v sin theta. So instead of doing so many things, I can just write the particular equations out of here and we can create that, right or not? So this is the best trick of what we can say equation of trajectory. Now, I can write this equation of trajectory in terms of range also. The point is, I can also write this equation of trajectory in terms of range, and that can be written as y is equal to what? X 1 minus x by r into tan theta, right or not? So this is the equation for the particular y when we have the ranges over there. Okay. Now, one thing is very peculiar over here, that this range has two important points. Range will be again following this particular case. Okay, like this normal cases of range. Okay. Now, if you try to involve something, like let's suppose if the particle is thrown with some different angles, let's suppose particle starts from here, so at that case the range equation will change. It will not be the similar equation which we are utilizing over here. Okay, so therefore you need to be very careful while using this r. Okay, why? Because r varies with respect to the trajectory. Okay, whatever trajectory you will have different kinds of range formula. Okay, So based upon that, we'll try to solve one question. Now look over this question number 1, or extra you can say, star mark. What it is saying, a jet of water is projected at an angle of theta is equal to 45 degree with the horizontal from point A. So this is my point A. From this, is this question is visible to all of you guys or not? Tell me. Okay, so what is the question? A jet of water is projected at an angle of theta is equal to 45 degree with the horizontal from point A, which is situated at a distance x is equal to OA. Now, question is that first case you have to consider this x to be equal to how much? 1 by 2 meter, and in second case you have to consider this x to be equal to how much? 2 meters from the vertical wall. Okay. Now the question is, if the speed of projection is root 10 meter per second, find the point P of a striking of water jet with the vertical wall. Means you have to calculate that where this particular water is hitting the particular point on this particular vertical wall. Now you know that if the particular water is hitting somewhere over here, it will have some components of x comma y. Yes or no? Means the particular point P will have some coordinates x comma y, and you have to calculate that this point is going to have some x comma y coordinate, and this is you need to calculate. So how to calculate? Can anyone try this? I'll give you 2 minutes time. I'll give you 2 minutes time. Okay. It has bana. Mansu. हाँ. ओ, हाँ देखो. अच्छा अच्छा देखो कौन सा फॉर्मूला यूज करेंगे, कौन सा फॉर्मूला इजी रहेगा. दो फॉर्मूला बताया हूं. लाइक आई हैव टोल्ड अबाउट यू गाइस टू फॉर्मूलास. वन based upon the angle theta, and this is related to x and initial velocity g and all those things. Second equation, you see that a range is provided over here. Now you try to go over the question. What you see that when the particle, when the jet is thrown, when the water jet is thrown, it is covering some distance x over here. Okay, on the horizontal. Yes or no? Now if it is covering some distance x over here, what is the property of it? Means, is this distance x, can I call this as a range? Means, can I call this as the point where the particular, okay, sorry, 1 minute. It's not the range. Means it is what, x is the coordinate where water should hit. Water should hit. Okay. Now, if you are aware of this x point over here, you can calculate. You can try to calculate the range over here or not. So to get the value of range, what is required? First, you need to first you need to have y value over here. So to be aware of that, try to apply something. Okay, angle is given. I have, see, x coordinate is mentioned where water should hit. Y, we need to follow one equation. Y is equal to x tan theta 1 minus x by r. This is the equation which we are going to follow so as to calculate that at what point on the vertical displacement from the x this particular particle is hitting. But for that we need the value of range. So what is this range going to be? Tell me. Uh-huh. Can you calculate this range? So what is the formula? U square sine 2 theta upon g. Yes or no? Now u is what? Initial velocity is how much? Root 10. Okay, so initial velocity is given root 10 meter per second. So that is what, 10 sine 2 theta means sine 90 degree. Okay, divided by g value is how much? 10. So what is the range of the particle? 1 meter. Hitesh, are you able to see this question? Anita, Anuj, Nissan, Ankit join nahi kiya na aaj. Okay, Sneha and all. Okay, so now look over here. What is the thing? That range of the particle is how much? 1 meter over here. Now, if you got the range over here, you can apply this over here. Yes or no? So, what is the equation? So, first point, look over here. For case A, we are calculating x coordinate of the particle, where the particle should hit on the x coordinate 1 by 2. Okay, so if it is hitting at 1 by 2, what we need to calculate? first we need to get the y value, then we can know that what is the point where this particular thing is going to hit. So therefore, I will apply the equation y is equal to 1 by 2 into tan 45, okay, minus 1 minus x, that is 1 by 2, range is how much? 1. So what you get from here, I think you will get 1 by 2, 1 by 2 minus 1, and this is 1 by 4 meter. So let's suppose if the particular part where water is thrown at how much distance? Distance of x is equal to 1 by 2. At what point we are going to see that water is getting heated on the vertical wall? At the coordinate P4x is equal to 1 by 2 is having the coordinates 1 by 2 comma 1 by 4. So at this point the particular water is going to hit, right or not? Yes or no? Now for case B, when x is equal to how much? It is possible. It's possible, Anush. हाँ, क्या क्या? What? What? So look over here. So if the range is 1 by 1 meter, so here x distance is 1 by 2, that is 0.5. Not so second case is 2 meter from the vertical. No problem with that. What is the problem with that? First, try to calculate. So if it is x is equal to 1 by 2, try to understand this. This wall is even on the negative y-axis, right or not? So you have to calculate first and check whether the displacement is coming as undefined or negative. So now look over here. So y is equal to what? 2 into tan 45 again into 1 minus 2 by 1. Now look over here. What you got as the relation? That it is equal to minus 2. Yes or no? I think y is equal to how much? Minus 2 you are getting. Now if y is equal to minus 2 meter, that means what? Where the particle is hitting. So therefore, for that particular case, where the particle is hitting over here, right or not? Means particular water is hitting over here. So therefore, for point when x is equal to 2 meters, actually the water instead of going over here, where the water is hitting, water is reaching its maximum height and it is coming to this point. Okay. So therefore, it is equal to how much? The coordinates are 2 comma minus 2 meter. Okay, so what is the particular range of the particle? It is equal to 2 comma minus 2. Right or not? Yes or no? What is the range? Range is just 1 meter. See, this, you have asked this a very good question. Sir, what is the definition of range? As you said, look over here. What is happening in the question? That your distance for consideration is larger than the range itself. Okay, means it is perfectly double of the range. Okay, so you asked me, sir, what will be like whether this many people will think that if the distance is larger than the range, then the projectile is not going to follow. Okay, so it is for which cases? See this. Try to understand this. Okay, see this. There are three cases over here which are forming. Okay, so this is there are three cases which are I'm going to take. One case, if projectile is thrown like this way, what it is going to see that this is if this is the range. So in first case, if in first case if I take x greater than range, then it is not defined case. Okay, right or not? Second case if I am throwing horizontally and if the particle is falling like this way, so this is R2 range, and again if I take this also x second case x greater than R, this is also not defined. Okay, but if I throw a particle from this top of tower with some initial velocity u, which is itself making some kind of angle theta with the vertical, there is a chance that the particle can cover some. Let's suppose if it is hitting over here, if I increase this initial velocity and some kind of angle theta, what will happen if I just shift this particular axis over here, over here? So what is going to happen? This particle will hit over somewhere over here, right or not? And if it hits over here, what will happen? This particle can even hit the particular axis downwards or not? Tell me yes or no? Are you getting me or not? Okay. So this is the case. This is the case that if I take this consideration, if I consider only till ground level, the particle will restrict the motion over here. But if I consider that there is also a depth in the down, so then the particle can also go down, yes or no? Because you have a net velocity component downward also. That day, yesterday, before this lecture, in projectile motion lecture 1 series, I have calculated that what is the resultant velocity in the towards the ground. You have to calculate. So this resultant velocity we have calculated already. So there is definitely a resultant velocity downwards also. If there is a depth, if I create one particular well over here, then the particle will hit the well at this position, right or not? So these are the cases. Understood? Yes or no? अच्छा मैं बोल रहा कि देखो, अगर पार्टिकल को हम थ्रो करते हैं एंगल थीटा पे, तो देखो, अगर मान लो तुम्हारा वर्टिकल वॉल सिर्फ ग्राउंड से ऊपर है, तो क्या होगा? अगर सिर्फ ग्राउंड से ऊपर रहेगा तो वो क्या करेगा, यहाँ पे आके रुक जाएगा, ठीक है। लेकिन अगर वॉल के नीचे अगर मैं एक वेल बना देता हूँ, कुआं बना देता हूँ, तो क्या होगा? पार्टिकल नीचे भी तो जा सकता है ना, क्योंकि उसके इनिशियल वेलोसिटी, रिजल्टेंट इनिशियल वेलोसिटी और रिजल्टेंट वेलोसिटी यहाँ पे एक रहती है, रिजल्टेंट वेलोसिटी टुवर्ड्स द ग्राउंड किसी एंगल पे रहती है। समझ में आया ना? हाँ 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 हाँ, ठीक है। हाँ, देखो, अगर तुम इनिशियल वेलोसिटी देते हो और थीटा देते हो और तुम बोलते हो कि मेरी एक ग्राउंड एक सॉलिड ऑब्जेक्ट है, तो रेंज तुम्हारा परफेक्टली डिफाइंड होगा फॉर्मूला से, यू स्क्वायर साइन 2 थीटा अपॉन जी। समझ में आया ना? यही फॉर्मूला अप्लाई करोगे और यही तुम्हारा रेंज का फॉर्मूला हो जाएगा, ठीक है। लेकिन अगर तुम्हारे पास वॉल अगर ऊपर नीचे वेरी कर सकता है, वाई एक्सिस में अगर हम पॉजिटिव वॉल भी ले सकते हैं, नेगेटिव वॉल भी ले सकते हैं, तो ये रेंज की डेफिनेशन चेंज हो जाएगी उस टाइम पे, ठीक है। समझ में आया ना? चलो, क्लियर है? आगे बढ़ते हैं। नेक्स्ट केस। सो हाँ, टेल मी। नहीं नहीं नहीं, एपरेंट हाइट का नहीं नहीं नहीं, इसमें कोई रोल नहीं है एपरेंट हाइट का। हाँ, no, this x coordinate, if x coordinate will be greater than r, if you consider the solid ground, so like particle is bouncing from this ground, then this x will be not defined. Like this case, if this wall, if I remove this wall from here, this particular wall, right or not? So if I remove this wall, this x greater than this 2 meter, which is greater than the range of the particle, will be not defined, right or not? It will not be. Always it will always be same. Yeah. Okay. Now moving to next case of horizontal projectile. Now there are three cases of horizontal projectile. Let's suppose if I have thrown the projectile with initial velocity u, which is not making any kind of angle theta with the vertical or something like that. So I have a mass of particle which is located over here. Okay, which I have given its horizontal velocity u, and I have just thrown it. Okay, so it is going to follow this kind of path. It will fall over you. Now, what has happened? It has traveled this displacement h without any kind of. Now, you try to see this for this particular projectile, the vertical velocity, whatever it is, this vertical velocity vy is going to be how much? Vertical initial velocity, you can say, is going to be how much? It is equal to 0. Okay, some guys like uh, Parinita, Sanjana, hello, you are able to understand. If you will not be able to, okay, if you will not be able to understand, then say me, okay. And yeah, so now look over here. What is the horizontal, like vertical speed, vertical initial speed? 0. So if vertical initial speed is 0, you know that the particle will have x component. This x range will be traveled by the particle, and this x range will be traveled in some time t, while this height y will be also traveled in some time t. So for the x, we know the equation. 1 minute, guys. X, that is equal to how much? Horizontal speed u into time t. For the vertical case, what is the equation? You have only 0 initial velocity, so that is equal to what? Half of gt square. Got it or not? Now, there is no acceleration along the horizontal, and there is an acceleration which is present along the vertical, that is equal to minus g. But displacement is also downward, so therefore the component of negative is getting cancelled. So here what you get as an equation for the projectile, so y is equal to half of z into x square by u square. This is the equation of the trajectory for the projectile which is moving horizontally. Got it or not? This is the equation for the trajectory of the projectile. Now look over here. If the total time of flight of the projectile is t, so what will be that value? What is going to be this value? So now look over here. See this. This y displacement is h. So that is equal to half of gt square, and the time of flight I can calculate from here. To travel this height means coming from here to here, what this it has done this displacement y in height h in some time t, and that's why we call this as time of flight, and that is equal to how much? T is equal to 2h upon g root over 2h upon g, and therefore as we know the time of flight which is equal to root over 2h upon g, we can know the range of the particle, and range of the particle is what? U into time t, or time of flight you can say, and therefore it is equal to how much? Root over 2h upon g. So this is the most easiest case. Let's suppose if we have thrown some kind of particle which has initial velocity u, perfectly horizontal, not making any kind of angle with the vertical or whatever it is. So then the particular time of traveling for the projectile is normal equation, that is equal to root over 2h by z, and the range traveled by that particular projectile along the horizontal path is equal to how much? U into root 2h upon g. So this is the most easiest one. Now I can just bring some changes in that. Consider a case 2. Okay, what is that case? Now you have the projectile itself, but this time the projectile is thrown with some kind of angle theta with the horizontal. But from where I will throw this projectile? I'll again throw the projectile from the top of tower only. But what we are doing is that we are trying to throw this particular projectile making angle theta with the horizontal itself. Now, if I consider this particular angle theta, what is going to happen? You try to see. The question, like, I'll just give you one thing, that find the time of flight. Just you have to do one thing, find the time of flight in this particular case, which I have given to you. Can you try? Anyone? Little bit try. Hitesh, यहीं पे हो ना? अनुज बोलना क्या हुआ? अरे तो ये बार बार नहीं करो, ठीक है? अदर्स, अहमद यहीं पे हो? ओके. देखो कैसे निकालोगे. हाँ, सोचो, अच्छे से सोचो. टाइम ऑफ फ्लाइट निकालने की कोशिश करो, देखता हूँ कैसे निकालते हो तुम लोग. ओके, थोड़ा सा चलो मैं थोड़ा सा हिंट दे देता हूँ, पहले नोटिस करो. हाँ हाँ, क्या? इक्वेशन तो बड़ा आएगा, ऑफ कोर्स इक्वेशन बड़ा आएगा. सो लुक ओवर हियर, यू हैव टू velocities. One, ux, that is equal to how much? U cos theta again. How many times I'll have to write here? U cos theta. One, a vertical initial velocity, that is equal to how much? Uy, and that is equal to how much? U sin theta. So you know your initial horizontal velocity and initial vertical velocity. Both of them you are aware of it. Now look over here. You try to understand. Uh, wait guys. Yeah. Now you try to understand, if the particle is moving from here to here. Try to understand, if the particle moves from here to here, does this displacement along the y-axis is 0 from this position O to B? So y along O to B, displacement along O to B is how much? It is equal to 0, because particle is starting from the reference level O, and it is again coming to the reference level O on. Got it? So first thing is displacement along OB is how much? 0. Now this displacement from O to B along the horizontal path, I call this as x. So I name x, or like particular displacement along O to B is how much along the horizontal path. It is just equal to x. Now you try to think. So two variables I have given to you. You try to think. It will give you some answers. Again, acceleration along the vertical, that is equal to minus z. acceleration along the horizontal, that is equal to 0. So what will be the condition? Same conditions. So now look over here. So first thing will be that this displacement x, whatever this displacement, total displacement, if we try to calculate, which we like call this as, this is called as the range, which is PD plus DC. Before going to that, first we need to calculate the equation of x, what the particle is following. That is equal to what? Again, acceleration along the horizontal is 0. So therefore, horizontal initial velocity, which is u cos theta, into total time of flight, a small t. So we are not taking, first we are not considering what is the total time of flight, because we are not aware that what is my time of flight over here. Are you able to get me or not? Okay. So before going to that, first you need to calculate the time of flight. So before reaching that, what I will do is I'll just create another equation. How? So look over here, try to understand the total displacement from this position. Again I'm saying, from this position, position of O to position of C, when the particle is traveling from O to C, try to understand what is the displacement in the particle along the vertical. What I am saying, what is the displacement along displacement of the particle? It is, what is the displacement? What is the displacement along the vertical? H. Himanshu? So look over here. If I consider from O to B, what is the displacement? Ahmad, Himanshu, Nissan, it is 0, right or not? But from B to point C, what has happened? The particle is traveling this displacement or not? Tell me yes or no, which is equal to how much? Minus S. Say in terms of sign convention, it will help you, right or not? So minus S is your displacement along the y-axis if the particle travels from O to C, right or not? So for that particular case, I'll write the equation minus of h is equal to how much? It is equal to u sine theta, which is your vertical velocity. Now this vertical velocity is along the positive initial vertical velocity. So therefore u sine theta is positive into time t minus, because the acceleration is again negative, minus half gt square. So this is your equation for the particle which is traveling from where to where? This is for y to O to C directly, right or not? This equation is for whole path from O to C. Got it? Yes or no? Are you able to get me or not? Okay. Now from this I can form the equation over here. What will be that equation? Try to understand. T I can write it as x by u cos theta. Yes or no? Or what you can try is like okay, I will write the equation. I will write what we can write. We can write gt square. I'll bring this over here. Gt square minus what that is, gt square. I'll bring this over here. It is equal to 2u sine theta into time t minus twice of h, and that is equal to how much? 0. Can I write this equation from this y of OC? I can write this equation. Now from this I can write the time of traveling, like this is my quadratic equation over here. So therefore I can write the time equation, which is equal to how much? This time equation is nothing but it is equal to minus of b, that is 2u sine theta, plus minus root over b square, that is 4u square sine square theta, minus 4ac. 4 4 2s are 8, so therefore that is 8 AC. AC is A is G and C is H. Okay. So for 8GH divided by what, guys? Divided by twice G. So minus of B plus minus root over B square minus 4AC divided by twice A. This is your particular quantity, roots of the quadratic equation. Now I can convert this into simple form. Uh-huh. Yeah, it will be a plus C. Okay. So I can convert this into the simple form. What that will be? It will be 2u sine theta or u sine theta upon g plus minus root over. I can bring this inside it and it will become u square sine square theta upon g plus what this will be, 4 to the 8 twice h upon g, right or not? So this is the total time equation, means this is the time equation for the particle which is traveling over here, which is following this particular path of the particle, right or not? Are you able to get me or not? Yes or no? हाँ हाँ, बताना क्या हिमांशु? नहीं। अच्छा एक बात बताओ, यही चीज बेस्ट पार्ट है प्रोजेक्टाइल का। एक बात बताओ, ये जो ट्राजेक्टरी है मींस दिस होल ट्राजेक्टरी इज ट्रैवल्ड इन द सेम वर्टिकल टाइम एंड हॉरिजॉन्टल टाइम और नॉट। मैंने ये बहुत अच्छी तरह से एक बार बताया था, तुम खुद नोटिस करो। ठीक है, ये क्लास में भी मैंने करवाया था, है ना? It is yes or no? कि if particle is traveling from here to here, you try to see this whole from here to here, this whole y displacement is traveled, like you try to understand this particle from here A to B. Okay, for this path, I know that what is my time of flight t. In this particular time of flight t, this particle is doing this y displacement or not? Tell me yes or no, Himanshu. And also in this time of flight only, it is doing x displacement or not? Tell me. Word or not? This is, so this is the general equation of time for the particle which is following over here. I didn't have even told that what is my time of flight over here still. Word or not? So in projectile, if you write the equation, you write x is equal to u cos theta into time t, and y you write u sin theta into time t minus half gt square. After that, you apply the condition of time of flight, that y is equal to 0 for total time of flight, and then you get the time equation or not, and then you get the ranges or not. So normal general equation is this only, which is, we can say here, this time we have taken as common. Why? Because let's suppose if the particle is coming at this position, this particle has traveled this path, and this path has been traveled in time t. That means what? Y coordinate has been traveled in the same time, and this x coordinate has been also traveled in the same time. Word on? Are you able to get me or not now? So general, हाँ 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 करेक्ट। हाँ ठीक है ना? तो ये तुम्हारे पास क्या हो गया, तुम्हारे पास टोटल टाइम ऑफ फ्लाइट का इक्वेशन हो गया। नाउ इफ यू नो द टोटल टाइम ऑफ फ्लाइट, if you know this whole time of flight, this is what time of flight equation. Okay, because already you have included that y displacement is how much, it is equal to h over here. So if you know this time of flight, can you calculate the horizontal range pc, which is equal to r, which is equal to what, u cos theta. Okay, u cos theta into this time of flight, which I denote also by capital T. So this is the time of flight, and you can calculate this range. So this range has a bigger equation, u cos theta into time t, means this whole big equation will be over this whole range, right or not? Now the most easiest trick is, as you are aware of this formula, do not do anything, just write the y equation when this kind of question will come. Just apply the height over here, then write the quadratic equation of time, get the two roots, negative root will be not considered, positive root will be considered, and apply this range concept, right or not? Are you able to get me or not? ओके, हितेश, समझ में आया ना? मस्त है ना? तो ये सारी चीजें हैं, ठीक है ना? नाउ अब देखो एक चीज नोटिस करना कि अगर तुमसे कोई पूछता है कि ये रेंज मैक्सिमम कब होगा, मींस व्हेन दिस रेंज इज गोइंग टू बी मैक्सिमम, इफ समवन आस्क यू। So now look over here. When you multiply, try to understand this whole sine theta and cos theta. When you multiply, you have the terms of time and range. Range has both the terms, cos theta also, sine theta also. Now you know that if there is a combination of sine theta and cos theta, remember this, try to understand. If there is a combination of sine theta into cos theta, this both of the values are at maximum at only 45 degree. Why? Because sine theta 45 is how much? 1 by root 2. Cos theta 45 is how much? 1 by root 2. And that is equal to just 1 by 2. If you take another angles, like let's suppose 30. So sine 30 is 1 by 2, while cos 30 is what? Root 3 by 2. If you take 90, cos 90 is what? 0, sin 90 is what? 1. Okay, so therefore the value becomes how much? 0. If you take 0 degree, sin 0 is what? 0, and cos 0 is what? 1. So again it becomes 0. So therefore, where the maximum value of sin theta into cos theta happens, it happens at what angle, guys? It happens at 45 degrees. So therefore, range is maximum when theta is how much, guys? It is equal to 45 degree. Got it or not? JEE 2000 2022. Got it or not? Are you able to get me or not? Easy. प्रीवियस, हाँ देख लो, ठीक है। मैंने क्या बोला कि साइन थीटा इंटू कॉस थीटा। नोटिस करो अगर मैं 0 डिग्री पुट करता हूं तो साइन 0 की वैल्यू होती है 0, कॉस 0 की वैल्यू होती है 1, वैल्यू 0, 90 डिग्री। हाँ हाँ, ओके ओके, ठीक है ना। तो ये सारी चीजें हैं इस केस में। नाउ second case is like the third case of the same projectile. What is that? I can throw the projectile instead of throwing it upwards, instead of throwing it perfectly horizontal. I can throw the projectile having the initial velocity making some kind of downward angle of inclination theta with the horizontal. The question is how to do it. Like what will be again time of traveling equation? Try to do it. Anyone? Again, all the things are available for you guys. Okay. The question is simple. Like if the particle is thrown with an initial velocity which is making a downward angle theta with the inclination with the horizontal, so you have to calculate again what time of flight for the particle and the horizontal range equation. Uh-huh. Think. Try to think. I have lost many YouTube videos subscribers now because I was not putting the videos from last long time. Even many people are not watching it live. हाँ हाँ, बट अभी देखते हैं, तो थोड़ा सा कम हो गया था इस बार। 7.4K only. They want some more subscribers. Okay, try to solve this problem. Try to think about this. OBS is working now. Okay, so yeah, that is a trick, Anup. Okay, so but I think you will a little bit get confused over the equation. So look over here, see this. Again, I can have two components. One along the horizontal perfectly, which is equal to how much? Ux cos theta. One perfectly along the vertical, but this time we have a downward vertical velocity. Are you able to get me or not? That is equal to how much? U sine theta. I do not write x over here. So you have horizontal velocity u cos theta, but you have this time initial vertical velocity, but in the downward direction, which is equal to u sine theta. So therefore, I'll write the components ux is equal to u cos theta, while uy, when you consider it, is equal to minus u sine theta. Got it or not? Equations are simple. X is equal to u cos theta, okay, into time t, while y is equal to this time minus of y is equal to what? Minus of u sine theta into time t minus of again half zt square. So equation changes to what? Y is equal to just u sine theta plus half zt square, and that is the very good point. I'll create one question out of this. Okay, please try to see that question. Okay, after this, right or not? Hitesh, Ahmad, समझ में आ रहा है ना? निशान नहीं है ना? ओके, so like Sanjana, now I'm going to proper advance. Okay, okay, I'm just removing these guys. Pranita, hello. Okay, let me first remove. Okay, now yeah, now we'll go to advanced level. So now look over here. What you have got? You have got x displacement that is equal to u cos theta into time t. Sanjana, are you here? Okay. So x is equal to what? U cos theta into time t, and y is equal to, this time the equations have changed to positive guys. Okay. So now look over here. I can write y displacement is how much? Again height. So therefore height is equal to how much? U sine, sorry, here time will be the u sine theta into time t plus half of zt square. Got it or not? Now look over here. If you know that height equation, I can write the equation in form of over here. What I will get? So that I am going to get it as zt square plus 2u sine theta into time t minus of twice its, and this is going to be equal to how much? 0. So therefore, what will be the equation of time? Time will be equal to minus of 2u sine theta, okay, plus minus root over b square, again that is going to be equal to 4u square sine square theta, no it or not, 4u square sine square theta minus, that will be plus again, yes or no, and that is going to be 8gh, right or not, divided by how much? Twice of g. I can write this equation in simple basic form, that total time of flight therefore is how much? As you know, I have put it y is equal to h, so total time of flight is nothing but u sine theta upon g plus minus root over u square sine square theta upon g plus sorry, g square over here, right or not? Hey, in this equation I have taken only g now, u square sine square theta, there will be g square over here, right or not? Okay, so u square sine square theta by g square plus 4 to the 8 twice h upon g. This is your total time of flight for the particle, which is again traveling with case 3. Right or not? Means if the particle is thrown with some initial velocity, which is making angle theta with the inclination downwards of the inclination. Okay. Now, this is your time period of time of flight, you can say. So range is simple again over here. Range is again given as u cos theta into this time of flight, and you will get the answer for it. Right or not? Yes or no? Are you get me or not? Okay. Now, one question I'm going to try. I'm trying to frame. Look over here. What is the question? That there is a, try to understand. Okay. There is a top of tower. Okay. I have one ground and I have one building over here. Okay. Means this is my building. What I'm doing? I'm taking three particles. Okay. Three particles. One particle A. I'm throwing this with, like, try to understand, one particle A, another particle B, and third particle C. Consider that the height of this particular tower is how much, guys? It is equal to h only. What is the height of the tower? H. The question is, let's suppose if the particle A is thrown with initial velocity u upwards. Okay. Second, if the particle B is thrown with initial velocity u downwards, and third particle is thrown with initial velocity u0, means it is dropped from the building downwards. Okay, the question is, let's suppose if the particle A is hitting the ground in time t1. So what is the question? If I'm writing, try to understand, the particle if the particles A, B, C hits the ground in time t1, okay, t2 and t3 respectively, find the relation in time t1, t2, t3. Find it, guys. Can you calculate? Do it fast. C is dropped from this building, okay, with initial velocity 0, means that it is dropped from rest condition, right or not? Okay. नहीं नहीं, ये प्रोजेक्टाइल नहीं, नॉर्मल केस है. Hey, you have learned it, huh? It is. It was in the DPP, yes or no? But solve again. Yeah. Okay. So now look over here. I'll solve this. Try to understand. For particle A, what is the path? Particle A will first go to the maximum height, then it will come down and it will hit the ground. Yes or no? Now try to see for particle A, still try to see. that the total displacement above this reference level is how much? 0. So y for particle A above this reference level is 0. But in the downward path, it is traveling some distance h or not. So therefore, I can like try to write. I will write the equation for particle A. Okay, particle A, that how much is the displacement in particle A? It is equal to minus of h. Why? Because the downward you are doing the displacement in the downward direction, and that is equal to minus h. And upward displacement is how much? It is 0. It is thrown with initial velocity u, which is in upward direction. So therefore, u into what? Time of t1. Now particle A is traveling through this ground in time t1. So time t1. Now acceleration is always negative. So minus of half gt. Sorry, small t, we have habit of writing small t t1 square. So therefore, what is the equation? Minus of h is equal to u t1 minus half g t1 square. That is the equation for particle A. Particle B, I'll write the equation. Now for particle B, what is the equation? Particle B is thrown with initial velocity downwards only. So this time minus of h, which is the displacement for the particle B. This is again the displacement for particle B, that is equal to minus of h, and initial velocity is downward, so minus of u into time, how much this particle is hitting the ground in time t2 minus half gt t2 square. What you got from the equation? U is equal to u of t2 plus of half of g of t2 square. For particle 3, means particle C, you can say, okay, what is the equation? Particle C is just doing its initial velocity is 0. Displacement is again towards the down, and that is equal to minus of h, which is equal to minus of half of gt g of t3 square. Got it or not? Yes or no? So you got the relation for all of them. All of them have similar displacement, that is equal to h. That's why you can create one relation between time t1, t2, and t3. Now look over here. Here minus minus got cancelled, and you can form the equation. Now how to do it? So consider this equation 1. Consider this as equation 2. Now you can do what? You can write over here h is equal to minus of u of t1 plus of half of z of t1 square. You can write both the equations over here. What I will get? I'll get as minus of u of t1 minus plus half of g of t1 square, and that is equal to what? U of t2 plus second equation, means this particular value and this particular value I am equating g of t2 square. Right or not? I can bring this over here towards this side, and I'll bring this towards this side. So what I will get? Okay, half of g common t1 square minus t2 square, and that is equal to how much? U of t2 plus of t1. Now you know that here I can a square minus b square form. It will be what? A plus b, a minus b. So therefore, what I can write? I can write the equation for initial velocity, and that initial velocity is how much? It is equal to, you can put it over here. But what is that, guys? It is equal to half of z of t1 minus t2. Right or not? Yes or no, guys? Okay. Now, based upon this, you try to put this initial velocity over here in any one of the equation. So in I'm writing in equation 1. So this is equal to h is equal to minus of u. U is how much? That is equal to, okay, put it in second equation. It will be very easy because already I have considered over here second equation. Okay. Okay. So I'm considering the second equation. I'm putting over here. So h is equal to u, that is half of t1 minus t2. So half of g t1 minus of t2 into t2 plus of half of g of t2 square. Got it or not? Now this t2 square and t2 square has been getting cancelled over here. What I get as the relation? H is equal to half of g of t1 into t2. So therefore this and these equations are similar, and therefore what you got as t3, you have got actually for t3, remember that t3 is equal to what? Root over t1 into t2, not t2 is equal to t1 into t3, right or not? What is that? For raised equation, t3 is equal to root over t1 into t2, right or not? Yes or no? Are you able to get me? Easy? Yes or no? So this is a question which I was missing from so many times, and I was trying to solve it. Okay. Now look over here. Apart from this, whatever these cases are there for the projectile, will include some problems and we will try to solve it. Okay. Now, we are going to consider next case of projectile, and the what is that? Projectile motion along the inclined plane, which is very important. Right or not? Because this is the thing which is going to come in your exams, and there will be definitely one or two questions asked on that. So now look over here. We are not considering the normal cases where the horizontal speed is perfectly initial velocity is perfectly vertical or something like that. What we are considering that the projectile, let's suppose if we have an inclined plane, okay, means this inclination is there. There is a particular plane which is making angle beta with the horizontal. What is the angle of the inclined plane? Beta with the horizontal. Now I have the particle of mass m. Okay, why I am considering mass m? It will help you later on. Okay, so I have the particle of mass m which is thrown with some kind of initial velocity, and that is equal to how much? U, and which is itself making how much angle with the incline, means horizontal perfectly, and that is equal to how much? Alpha. Now as you know that for this initial velocity there will be two components, one along the inclined plane, yes or no, one perpendicular to the inclined plane. Got it or not, guys? Yes or no? Okay, now if I consider along the inclined plane, means if the particle, if I consider that at what angle this particle is thrown with the angle with the inclined plane. Now this is my angle with the inclined plane or not? Tell me. This is my angle with the inclined plane, and what is this angle is going to be? This angle is going to be equal to, this angle is how much? It is equal to, I'll write over here, alpha minus beta. So what is the horizontal component? U cos, okay, U cos alpha minus beta, right or not? Okay, and what is the vertical component? U sin alpha minus beta. Are you able to get me or not? Yes or no? Now look over here. You have the particular in the vertical direction acceleration due to gravity or not? Tell me yes or no. So acceleration due to gravity acts along the vertical direction. But again, it will have two components. One perpendicular to the inclined plane, which is equal to how much? G. Let's suppose if this is angle beta. So what is going to happen? This angle is also going to be, you know that this angle is also going to be how much? It is going to be beta. So what is the perpendicular gravity component? Minus of G cos beta along the inclined plane. Again, G will have one of its component, and that is equal to how much? It is equal to minus G sin beta. Are you able to get me or not? So I have taken all the components of initial velocity and also the components of gravity. Got it, guys? Okay. क्या 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 बताओ? अरे ये एंगल अगर बीटा है तो ये एंगल भी बीटा हो जाएगा ना. नोटिस करो कैसे. देखो इधर देखो, अगर मैं इसको स्ट्रेच कर दिया, ठीक है, तो देखो ये एंगल बीटा होगा कि नहीं होगा. अब ये जो होता है ये तो तुम्हारा नॉर्मल हो गया इसके साथ, तो ये एंगल कितना हो गया? 90 माइनस बीटा. जब ये 90 माइनस बीटा हुआ तो ये एंगल कितना होगा तुम्हारे पास? ये और ये दोनों, ये जो एक्सिस है ये वाला और ये वाला आपस में 90 डिग्री फॉर्म करते हैं, तो ये एंगल कितना हो गया तुम्हारे पास? बीटा. समझ में आया कि नहीं आया? ठीक है ना. सो दैट इज द रीजन. ओके, आई एम इरेजिंग दिस. ओके, now look over here. If you got this particular angles over here, if you perfectly got the angles, now you can try to do the problem. So look over here. Let's suppose the particle, I'm considering one thing that let's suppose this horizontal, this range on the inclined plane be how much? R. What I'm saying? Range on the inclined plane. R is what? Range on inclined plane. Okay. And this projectile is also have maximum height with respect to inclined plane or not? This is called as maximum height, H max. So you have to calculate both of these. How to calculate it? Tell me how. Any idea? Oh, how to do it? Again, I can write the equations or not. Look over here. What is given? U of x is given. That is equal to U cos alpha minus beta. I am considering. Right or not? Okay. Now, second case. What is U of y? U sin alpha minus beta. A of x minus of g sine beta a of y minus of g cos, sorry, 1 minute, beta minus of g cos beta. So you have got the relations over here, and you can try to write the equation for y. Y will be what? What is the initial velocity along y? That is equal to u sine alpha minus beta. So u sine alpha minus beta, got it or not, into how much time? Time t minus half of g. What is acceleration along the particular y direction? That is equal to g cos beta or not. So g cos beta into time t square. This is the y equation, not the simple form. Previously, what we used to consider? We used to consider y is equal to just g. Here, the value of g is also changing. That is equal to how much? Minus of g cos beta into t square. Got it or not? Hitesh, Anuj, Himanshu, got it? Okay. Now, as you know the y equation, can you calculate a particular time of flight? You know, if I consider a small t to be equal to time of flight, what will happen? Your vertical displacement or y is equal to going to be 0, because see this is the ground level of the projectile, means you can say this is the ground level of the projectile on the inclined plane, and here it is hitting. So from here to here, from O to B, this y displacement is getting 0. So therefore time of flight is going to be how much? It is going to be equal to u2 u sine alpha. I'm writing directly, I'm not going to derive. Okay, 2 u sine alpha minus beta divided by g of cos beta, right or not? So just little bit of changes. Previously, time of flight was 2u sine theta upon g. Here, this time we have to consider the components, right or not? That is equal to 2u sine alpha minus beta divided by g cos beta, right or not? Yes or no? Are able to get me or not? Oh, yes, sir. Okay. Now, what is the range? Range along the inclined plane, that is equal to how much? U cos alpha minus beta into what? Time t or not? Tell me yes or no. That is time of flight, capital T. So what I get as the relation? I get it as 2u square. Okay, 2u square. One thing is there, guys. What is that thing? One thing is there. Wait. Okay. Wait. What I will do is first I'll write the x equation. Okay. So look over. What is the x equation? U cos theta. Sorry, u cos alpha minus beta into time t. Right or not? Okay. And therefore, what I get as the relation, u cos alpha minus beta in total time of flight 2u sine alpha minus beta divided by g cos beta. Simple. Yes or no? Now look over here. I'm just going to minimize this friends. Okay. Ah, what? इंटरनेट ओवर? अच्छा okay. तो एक काम करो, लीव कर लो, कोई दिक्कत नहीं है, यूट्यूब पे मैं डाल दूंगा अभी आधे घंटे का बस वीडियो 1.5 पे लगा के देख लेना, है ना? ठीक है, हाँ ठीक है ना? सो नाउ लुक ओवर हियर. So x is equal to what? U cos alpha minus beta to u sin alpha minus beta into g cos beta. Now look over here. I can form the equation or not? That x is going to be equal to how much? 2u square cos alpha minus beta and sin alpha minus beta divided by what, guys? G cos beta. Right or not? Write this up to this point. It is written. Tell me. U square sine 2 of alpha minus beta. Yeah, that is the x. Okay. Now x are along the inclined plane is this only. Okay. Now if someone asks you that what is the horizontal, what is the value of this r, means I am writing it. What is the value of r along the horizontal? Right or not? This is the r along the horizontal or not? So this is r prime I'm considering. R prime is what? R range along horizontal. So this is going to be how much? This is if I get the value of r and I know the value of beta, so this base is going to be how much? R divided by cos beta. Yes or no? See this. Is this is this r is going to be my hypotenuse for this particular triangle? Try to consider. Yes or no? So look over here. This is my triangle over here. Okay. This angle is beta. You are aware of this r and you have to calculate r prime. So cos beta is equal to what? Base by hypotenuse. So base by r. So I can write cos beta is equal to r prime divided by r. So r prime is nothing but it is equal to what? A. R prime is nothing but it is equal to what? R into cos beta. Got it or not? Yes or no? So if you are aware of this, you can calculate the answer out of it. Got it or not? And what is that going to be? Wait. Here, range along inclined plane is what we have calculated x. X is u square. Okay, I have written this x for uh, horizontal plane. Okay. Oh shit, yeah. One thing is there. Okay. Okay. So with respect to inclined plane, this is going to be how much? Simple. R cos beta, and that is equal to how much? 2u square sine 2 alpha minus beta divided by g. So this is the value of r prime when you consider this particular values. Are you able to get me or not? What I'm saying, guys, simple. Look over here. What I'm saying, that this r prime is nothing but how much? R is given as this value. Yes or no? This is my value. Cos beta and cos beta will get cancelled, and what you got? 2u square cos 2 sorry 2u square sine 2 alpha minus beta divided by g, and this is my r prime along or r prime or the range along this x direction. Now you try to understand what I have done. I have written this y for which case? I have written this y for incline. I am taking the incline as my reference frame. Okay, which is my reference frame? Inclined. Okay, incline is my reference frame. I am considering this x is equal to r, means this path, this whole path has my x value, got it or not? So therefore, I am getting the different answer. If you see, if you go to different books, what you will get? You will get again different answers, got it or not? Hitesh, Anush, are you will get me or not? In many books, what they will do, see this. In many books, what they are going to do is, okay, so especially I'm talking about like some different books or something like that, that they will consider this as y. Okay, actually this is correct also, that I will consider this as my y axis and this as my x axis. Yes or no? So at that time you try to understand along the x axis, try to understand y-axis will have similar equation, but if I have thrown the particle with some initial velocity u, okay, which is making some kind of angle theta with the x-axis this time. So what will be my horizontal, like initial velocity along x-axis? That is going to be u cos theta, right or not? Time of flight still remains same, but the equation of x changes over here. If I consider this equation, time of flight, try to understand, this time of flight remains same because y we have calculated, y is just vertical, but equation of x changes, and that is going to be how much? U cos theta, sorry, u cos theta into time t, and therefore x is going to be how much? U cos theta into time t is how much, guys? Time t is nothing but it is equal to u cos like if you multiply 2u sine alpha minus beta divided by g cos beta, 2u sine alpha minus beta divided by g cos beta. So I have done both cases. See this thing, this particular case with which I have done, you will find it out in Senge's, and this case particularly you will find it out in MRB and DC Pandey. Got it or not? Means this particular equation you will find out in which books? MRB and DC Pandey. This equation you will find it out in which book? Senge's. Got it or not? So both books I have done. Okay. So हितेश अनुज समझ में आया ना? ठीक है, तो इसको देखो, अभी मैं इसको सिंप्लीफाई करूंगा, क्या हो जाएगा ये? x इज इक्वल टू व्हाट? 2u स्क्वायर cos थीटा इनटू व्हाट? सॉरी, यहाँ पे अल्फा हम लोगों ने लिया है ना, ठीक है, अल्फा चेंज कर दो यार, वेरिएबल सेम रखो, ठीक है ना। सो कॉस अल्फा, बस यही हो गया, 2a² कॉस अल्फा साइन अल्फा माइनस बीटा डिवाइड बाई जी कॉस बीटा। समझ में आया ना। अब देखो, अब ये तुम्हारे पास x मिल गया। अब उन्होंने क्या किया, अब उसके बाद उन्होंने r प्राइम ये वाला, मतलब जब तुमने x कैलकुलेट कर लिया उसके बाद उन्होंने क्या किया है, इस r प्राइम को कैलकुलेट किया है ना। सो देयर आर डिफरेंट वेज, जस्ट 1 मिनट, देयर आर डिफरेंट वेज। Okay, so are you with me or not? अनुज, समझ में आया ना। तो देखो, इन सारी चीजों को यूटिलाइज करके तुम क्या कर सकते हो, रेंज की इक्वेशन फाइंड आउट कर सकते हो। मींस यू कैन ट्राई टू कैलकुलेट द रेंज इक्वेशन एंड यू कैन ट्राई टू सी। ओके, सो दिस इज द केस फॉर प्रोजेक्टाइल ऑन द इंक्लाइन प्लेन। अनुज, क्लियर है? Okay, now if we get this particular case, we can apply this and we can calculate the R max and R some kind of height max or something like that. Okay. So there are still 2 to 3 more cases of projectile which are left. This particular case when I drop the projectile from the inclined plane, and second, like I'll do some problems based upon this. There are 3 to 4 problems over here. Okay, and after that, relative motion of projectiles, and yeah. So still some 2 more cases are left. Okay, and which we are going to include it tomorrow, right or not. So first what I will do tomorrow, first I will discuss this case, this particular case, and then after this what I am going to do, after this I am going to discuss this relative velocity of projectiles, and after this I'll solve these problems. Got it? Yes or no? That will be a better idea. It is Anuj. Okay, and Anuj, रेन एंड मैन डन अनुज, इसका वीडियो भी मैं डाल चुका हूँ, है ना।